We're inside a unique experimental metallurgy plant. This site is currently being used to study how to recycle what is known as red mud, the waste coming from primary aluminium production. To figure out more efficient and sustainable ways to reprocess that waste, researchers need this furnace to reach 1400 Celsius. At this research facility, waste from primary aluminium production is mixed with carbon and then melted at very high temperatures. The resulting mixture is a treasure trove which can be reused in the steel industry.
Of course we are interested in the value of these metals inside red mud. Firstly, there's a bit of aluminium, iron, scandium, a high-technology metal, maybe titanium, and also other metals which are rare earth minerals.
Every year, approximately 150 million tons of red mud are produced around the world, but less than 2% of that is used again. A process called thermal approach helps to transform the red mud into a mixture rich in iron.
In order to recover the iron, we must use very high temperatures so that the metal melts. We must work with the waste in many different states: dry, hot, acid, alkaline. Our research aims to optimize techniques in order to find the right way to recycle red mud.
But there are other, more imaginative ways to recycle this red waste. Here in Belgium, red mud is heated at lower temperatures, around 1300 Celsius. Scientists from this European research project have come up with some creative solutions.
At this lab furnace, we melt the waste. Once that metal waste has melted, we cool it down in a bucket. The final product we recover is similar to glass, and it can eventually be used as a reactive substance for making construction materials, for instance.
At first, the resulting material is closely analysed to determine its internal composition.
We can have an exact quantification of which elements are in it and also in which concentration. And we can go up to really low concentrations of silicon, aluminum, calcium, sodium, oxygen that are in it.
Red mud glass is then grounded and mixed with sand and graphite to produce construction materials like bricks, lightweight aggregates, or even roof or floor tiles.
For us, it's important that we minimize the global dioxide, carbon dioxide production. And not only that, we also have an eye on the global or the wider environmental footprint. These products are more green in the sense that they have been using only residues, and we want to do that without compromising properties, so both mechanical and physical properties.
Researchers say they hope their efforts will increase red mud recycling fivefold in the next decade.